Thank you, Mr. Chairman. When the chairman asked me for a title of the fact sheet, I was a little bit embarrassed because I was not in Istanbul, so I was not clear what a fact sheet was supposed to be. So, the microphone? Yes. So, I stay seated. No, it's better then. And so, the title contains two concepts. Elaboration, to show that we are looking to the future rather than to the past. And then there is a reference to an experimental campaign on a timber footbridge. Actually, we had two footbridges on which we had access continuously, and we can consider ourselves the owner of the collected data. So this gives us a possibility to repeat experiments and to consider there as our test field. Is very common that when you perform a experimental campaign, then you are not the owner of the data, and so it's difficult to publish them and to repeat experiments and so on. In these cases, we had this possibility, and so I just wanted to give the reference. The paper was just published in the Journal of Structural Control and Monitoring in the issue of April. So people that is interested to this campaign are addressed to this paper. One of these of the footbridge is this one. It looks like a cable stayed bridge, but it's not a cable stayed because the stays are not cable but are pipe element. So we had an experiment on this, and the other one is a footbridge with a cable. Is 100 meter long, and as I said, we have a continuous access. When we did previous experiments, I give you just an example. This is, for instance, something that Ramon Casas did more than 10 years ago, going around with a hammer on the cable and checking what occurred. And you see the red and the blue line correspond to an excitation in the horizontal direction on the cable, and the other one in the vertical direction, and the periodogram show exactly the harmonic from which you can have the tension in the cable, and so and so. Okay. This is the past, and we obtained these results by standard accelerometer with technology that is good in terms of wireless, power harvesting, real-time communication, and so on. And for that I have seen this morning, there are, in the other application I have seen, people was using a strain gauge, was using most of the strain gauge were fiber grating, and there are other techniques that seems to be consolidated as vision-based, as a laser scanner, radar scanner. All these could be considered as consolidated. But I would like to present today something that occurred to me in a parallel project, and from that I start a new, let me say, wish of research. Let me conclude about the footbridge. Of course, the main loading are wind or pedestrian walking, pedestrian running. Cunha already gave us some idea. Before entering the concept, I would like just to say that because this is an European project, it is important to speak a little bit about the Galileo delay. today is 2016. I remember that the first date for Galileo was 2012, and now is planned for 2020. So we are in a period, we Europeans are in a period in which we have a good challenge for the future, and unfortunately, a continuous delay, a gap that prevents us from using our own technology. We addressed this topic by using a simulator. I want just to make aware of you that there is the possibility to use a simulator in which you can simulate which will be the signal produced by Galileo, so you can produce exactly your land device as tomorrow will be used when Galileo is working. And I wanted just to give you an example, but before, sorry, the slide was prepared for another, oh, sorry. In this slide, I also show you that in order to have good precision with the GPS system, or Galileo when it will be working, there is a concept, something difficult to incorporate, and is that it's not enough to have one device. You have to have at least two. You have to have also the rover. And this will require a sort of change of mind in the engineer that would like to use GPS. Of course, all of you probably know that the GPS up to now is used only for structure that give a very large displacement, as a suspension bridge, cable stay bridge, and a skyscraper. But the precision of this method, and mainly with the Galileo will be available, is increasing and increasing. Now, let me go to the next slide. The reason I met this problem is that I am involved in a project that has nothing to do with our world, is security, and is regarding to equip train, truck, and so on with a system monitoring their position in view of security issue, and mainly in view in order to monitor these even up to 24 hours after a catastrophic event. So you have to provide energy, real-time communication, you cannot rely on internet and so on. That was the project. But in order to do this, we had to produce some devices, and the slide on your left is just a comparison of the actual map, the actual trajectory we did by the device, and the simulation of the data that we obtained by Galileo. So you see, we were able to show which will be the position of our device when Galileo will be operating. Of course, we had to use the simulation in order to test something that will be working 4 years from now. The device is something that I show in your right, and this is the starting point of my communication, because all of you presented your contribution assuming that the data were suitable. But the data are collected by devices. These devices are in evolution. And one of the main important evolution that is collected by a sensor as the red box that is here, it is that it includes a lot of software, because it is a system coming with GPS information, but also exploit internal inertial sensor, and not only one, but a mount inside the box, that is just a box of this type, 3 accelerometer, 3 inclinometer, and 3 magnetoscope. And the 3 means that you want to have an average on the 3 measure, and also that the coupling of many instruments means that you are using a sequence of Kalman filter to produce a signal that is very, very clean. Nothing to do with the past, that there was noise and so on. The signal is cleaned, but is cleaned by the software. So you have to be sure that that software is not preventing you of something that is important for you. And another thing that is quite important is that the information, the signal, is no longer analog, but is digital. And the software decides which is the rate, 1 per second, 1 per minute, or less. And this is something that the user have to understand well. These devices are still very expensive, so probably for some years no civil engineer will use them. But they are on the market. And the idea that we had is to use these devices on the footbridges I showed you at the beginning, and the results will be made available in the Bilbao conference, where most of us will meet in next July. Essentially, going to the scientific technical term, I check the chairman that is not looking me in too bad way, but I have still 2 minutes, I think. The term is OEM. OEM stands for Original Equipment Manufacturer, and is something that the producer offers on the market according to this description. But essentially, when we go to what they are producing a sort of multi-constellation in the sense that are working with GPS, with Galileo, and so, and multi-frequency satellite position receiver, which mount already inertial sensor. So give exactly the same information that was illustrated before. And if you go to a web page, you can find something as this. This is the offer of the market. And in my opinion, we as a civil engineer have to understand if we are interested in using this kind of device or not. So let me summarize. They offer us the position from the GPS, and most of you will think, okay, that is fine for horizontal. Be careful. They start also to give you information on the vertical. So when I will mount it on a cable, I would like to see what exactly is the added information I receive by using this 3-direction positioning action. But also there is the filtering by the software that is installed in that could be very interesting or very dangerous for the application. And also there is the digital issue that is not a minor issue that must be considered. Well, this is the device we are testing. For the moment, we are just waiting a better time. It's still cool for going on the field. In April, we will perform the test on the footbridge. As I said, we will report in Bilbao. Conclusion. Having the availability of a test field represented by a testing footbridge of 100 meters long, having access to OEM technology with their integrated device, so the problem is to discover which is the role of the integrated devices on this. The goal is to exploit the offer by enhancing the potential of the new market offer. Thank you for your attention.